Dear students, we are going to start the second chapter of this module, fourth module. This exercise chapter is regression. So let us start. What is regression? So regression is a statistical technique to model the predictive relationship between several independent variables and one dependent variable. So it is a technique to establish uh, relationship between several independent variable and one dependent variable. Uh, so suppose we have a, equation like y equal to x1 plus x2 plus x3. So here x1, x2, x3 are independent variable and y is the dependent variable. Regression is a kind of technique which establishes the relationship between independent variables like x1, x2, x3 and dependent variable, that is y. So the objective is to find the best fitting curve for a dependent variable in a multi-dimensional space with each independent variables being a dimension. So, what is the objective of this regression is to find a best fitting curve between uh, dependent variable and independent variables. The curve could be a straight line or it could be a non-linear curve. It can be a linear or non-linear curve. The graph which it shows. The quality of fit of the curve is the data. The quality of fit of the curve to the data can be measured by a coefficient of correlation R, which is the square root of amount of the variance explained by the curve. So here uh, uh, we find out the coefficient of correlation, that is the symbol small r is there, and with a mathematical equation we will find out in square root of that value, that will give you the variance. So let us see how to find the regression. So key steps for finding regression. So list all the first step is to list out all the variables available for the making the model. Then establish a dependent variable of interest. What dependent variable we have to find out, and what are the independent variables are there. Examine visual relationship between variables of interest. Find a way to predict dependent variable using other variables. So we have to find out some relationship between dependent variable and independent variable. Uh, Correlation and relationships. So let us see. The first and foremost measure of the strength of relationship is the correlation. We have to find out a correlation. Uh, the strength of correlation is a quantitative measure that is measured in a normalized range between 0 and 1. So it's the value of correlation lie between 0 and 1. If correlation is 1, it indicates that it is both the variables are fully related. Variables are in perfect synchronized, means they are directly related with each other. And if correlation value 0, it indicates that there is no relationship between dependent variable and independent variables. So given two numerical, this is the formula to find out the coefficient of correlation, that is small r, that is sigma x minus x bar into y minus y bar divided by square root of x minus x bar square into y minus y bar square. Here x bar is nothing but it is a mean value, average value of all the x variables, and y bar is the mean value of all the y variable. So using this formula we find the coefficient of correlation, that is r. Here x bar, it is mean of x, and y bar it is a mean of y variable. So let us go ahead. Here a scattered plot, or that is called a scattered diagram, is a simple exercise for plotting all data points between two variables on a two-dimensional graph. So suppose here x and y, two uh, variables are there, where x is independent variable and y is dependent variable. Then what are the different relationship we can establish, or what are the different scatter diagram we can get it? So you can see the first A. So it is a direct linear graph, it is a straight line. In the second case, B case, you can see it is the uh, linear, but it is in reverse order. If x is increasing, y is decreasing. The x is minimum, y is maximum. But here in the first case, x is increasing, y is also increasing. So x and y directly proportional it is there. But here it is inversely proportional. In C, there is a relation between x and y, and that is inversely proportional, decreasing only. But it is a curvilinear, it is not exact straight. So if x is increasing, you can see that y is decreasing, but it is not decreasing in a straight line. It is decreasing in a curve manner. Then here come to the D. D is also increasing, but it is not a straight line. When x is increasing, y is also increasing, but it is not a curve line. It is a it is not a straight line. It is increasing in a curved way. Similarly, here uh, no relationship. In E, there is no relationship between x and y. You can say that when x is increasing, y is also increasing or decreasing. Similarly, in F case also, there is no relationship between x and y. So many data you can see that if it is increasing, some data decreasing, and some data are constant. So there is no relationship between, in example, E and F. Now that's what everything is explained here, whatever I explained in the previous diagram. So let us study the above concept with one example. Here we have a table in which house prices are given, and based on the size of the house. So here, like if the size of the house is 1850 square feet, its price is 2,29,500. If a house size is 2,190 square feet, then its house price is 2,73,300. Similarly, it is like different. So this is the continuation of the first table. This is not another table. This is the continuation of the first table. You can see. So based on this, we have to predict price of some house which which size is given. Suppose like a 1500 house I want to buy for 1500 square feet. What would be the price of that? So based on the given data, we will try to find out the price. So the two-dimensional dimensions of one predictor, one outcome variable data can be plotted on a scatter diagram. A scatter plot with a best fitting line looks like the given graph. So based on 0 to 3000 square feet of house, that house price is plotted in the diagram. So what we got, we got a linear, there is a linear relationship. So we calculate running a regression model between the two variables produces the following two outputs. So based on the